Hello, so we're going to start on surface area, and we're going to start with prisms and cylinders today. So a prism, again, is like a box. So to draw a prism, um, make it look three-dimensional, we're going to just do a rectangular box. You will draw something that looks more like a rhombus here. And then above that, you want to draw one that looks just like that. So you have two, those are called bases. Okay, then you just connect the corresponding points, vertices, and that is your box. You might have to pause and finish that for yourself. So if we're doing surface area, you want to figure out the area of each one of these, what are called faces. So you have the bases that are faces. That would be this guy on the bottom and this guy on the top. And a capital B stands for base area. Okay, and then you have all of the rectangles around the outside, and that's called the lateral area. So the lateral area or sometimes just called LA, would be all of those rectangles. Now, I don't know, I can't tell you in general how many rectangles because it depends on the shape. So, for example, I have some prisms here for you. That's why I have the camera on me. So, for example, the one that we just drew has a rectangle base. So there you would get, as you can see around on the lateral part, you would get 4 rectangles for a total of 6 rectangles, 2 bases and 4 lateral. Now, if you had something like this, notice that the base is a hexagon. So a hexagon prism, when you open that up, you end up with 6 rectangles. Okay, so I have 2 hexagons and then 6 rectangles as my lateral area. So it depends on what your base shape is, which will tell you how many rectangles you have. Okay, if I had a triangle base, so here's a triangle base, then I only have 3 rectangles. So I would have the 2 bases and then 3 rectangles to make my prism. Okay, so my general formula for a prism is that I'm going to have 2 bases. So whatever the base area is, could be a hexagon, could be a triangle, could be a rectangle. And then you add all of those rectangles. And again, the number of rectangles depends on the shape of the base as well. So this is the general formula, 2 bases plus all of the rectangles for the lateral area. Okay, cylinder actually looks similar to a prism. The difference is that for a cylinder, the bases are circles. Now, to make a circle look three-dimensional, you draw it more like an oval shape like I did. And you're going to draw 2 ovals, and then you just connect the outsides. Didn't connect that one very well. Okay, so the bases here are going to be circles. Okay, so here the base is 2 pi r squared. And just like with a prism, you are going to have 2 of those. So I'm going to have 2 bases, and then plus, so the lateral area of a cylinder is actually pretty interesting. So the lateral area, I will grab my cylinder. So here's a cylinder, right? It has that circle as the base. And then the lateral part, this part here, if you cut up the side of it and unravel this, it actually becomes a big rectangle. So here we have 2 circles, and then this rectangle, which is the lateral area. And that rectangle basically wraps around the base. So what you got to think about is the lateral area here, as I just showed you, this wraps around the base. So if you can imagine, let me highlight it, this part right here would wrap around the base. Well, what I just drew there was the circumference of the base. So this side of the rectangle is circumference, pi times diameter. And then the height, so we'll do that in a different color. The height here would be the same as that height of the lateral area. So that is going to be h. So to figure out the lateral area of a cylinder, you do pi times diameter times h. So pi d h. So you have two circles, the two bases, pi r squared, 2 pi r squared, plus circumference times the height, pi dh. And you can use your notes for any quizzes and tests, so you can, have these formulas at your disposal. But let's go through some examples of those. So we're going to do pyramid and code on the next video. So vocabulary, so I went through some of this, the bases. Again, this one's a pentagon, this one's a triangle. I showed you a hexagon, and we drew the rectangle, but the base can be any polygon. And then the lateral faces that these are pointing to are all of those rectangles. So if I was going to find the surface area of this rectangular prism, what I want you to do is actually draw out all of the shapes. Okay, so depending on the base, these rectangles are not always going to be the same. In this particular case, you'll notice that you have the front is different than the left and the right. Okay, top and bottom should always be the same. But drawing all of the rectangles, you have the top and the bottom are both 4 by 3. So you could even shade that in, but this is the base 4 by 3, and this is a base which is also 4 by 3. So that's 12 and 12. Okay, the front here is 4 by 8. So I have 4 by 8, and then the back is also 4 by 8. The left, however, the left over here is going to be 3 by 8. So the left is 3 by 8, and the right is 3 by 8. So you take the area of all of those rectangles, and you just add them together. So my total here, total surface area, would be 136 feet squared. Okay, so we're going to try one of those on your own. So notice that your bases here are triangles. So you want to think about the triangle formula for that. And then just be very, very careful, because you do need to figure out this side. Because this rectangle is part of the surface area. So remember, you're going to need to use something. I'll just give you a hint. It's the Pythagorean theorem. You're going to need to figure out this length using the Pythagorean theorem. Please draw all the shapes. So pause and try to find that surface area. Okay, so welcome back here. We're just going to start out with the base. So the base is a triangle with a 3 and a 4 for the base and the height of the triangle. There are 2 of those. So I'm going to do, and there's 2 of those. So I'm going to do base area here is 1/2, 3 times 4. And then we know that there are 2 of those, so we'll do that in a second here. But 3 times 4 is 12, half of 12 is 6 centimeters squared. So 2 bases would be 2 times 6, or in other words, 12 centimeters squared. Okay, so there's the 2 bases part of our surface area. Okay, then, like I said, you do need to figure out this length, and I gave you the hint that you're going to need to do Pythagorean theorem. So just going through that very quickly, 9 plus 16 is 25. You can do this in a calculator. Square root of 25 is 5. So I know that this length here is 5. Now, you just have to be careful because there are 3 different rectangles in this case. So my lateral area is going to be, this side over here is 3 by 8, or sorry, 3 by 6. Okay, and then I have the one here on the right is 4 by 6. And then I have the one in the front, which we just calculated, the 5, and that is 5 by 6. So area for the lateral area, the rectangles, I get 18, I get 24, and I get 30. So then at the very end here, you're going to do the full surface area. So my surface area for the 2 bases was 12. And then for the rectangles, I have 18 plus 24 plus 30. So grand total here, that's 30. So 84. You can use a calculator if you need to. Okay, if you want a little bit of a challenge, you can try this guy. This is definitely optional. Just be very careful because you do want to make sure you get every single surface. So like there's a surface back here, there's a surface on the bottom, there's another L-shaped in the back. So if you want to pause and give that a try, please do. Okay, if you tried it, the total surface area, so I did this, let me just look up what I wrote as, I'm not going to go through it with you. I got 242 feet squared. If you want to go through that in class, we can. Just ask. Okay, so going through a cylinder example. So you have right cylinders and oblique cylinders. There's actually oblique prisms as well. It just means it's sort of slanted. But you're always looking for that perpendicular height, even if it's tilted. We're really only going to deal with right cylinders though. So looking at right cylinders, again, we have the bases, we have that height, that perpendicular height, and drawing out the different shapes. So there's 2 bases, which are circles, pi r squared, and then we have, of course, pi times diameter, and then we have the height. So here, diameter, and I would recommend that you actually write out d equals 12 and r equals 6, just so when you're putting it into the formulas, you don't get mixed up. But the pi times diameter is 12 pi times 10, so that's 120 pi. These are each 36 pi. You add those 3 things together. Now notice they all have a pi symbol in them. Those are called like terms, just like if you had an x there. So you can add like terms. So that is a grand total of 192 pi feet squared. So this would be your surface area. Okay, so I would like you to pause and try this one on your own. Again, first thing I would do is write out the diameter and the radius, so you don't get that all mixed up. But the bases are circles, and they both have a radius of 4. So pi r squared would be 16 pi and 16 pi for a total of 32 pi. And that would be the bases. The lateral area, again, pi times diameter would be 8 pi times the 12. You can use a calculator, that's 96 pi. So you get a grand total here of 128 pi meters squared.